All right, now this graph, now if you notice, based on what we did last class period, does this graph represent a relation? Yes or no? Why does it represent a relation? It's a set of ordered pairs. That's basically the definition that we talked about. So if you notice that this relation right here, I'm sorry, this graph right here is made up of a set of ordered pairs. How many ordered pairs are on this graph? Negative number. And each ordered pair represents the solution to whatever equation this was, or this is, which you don't see it. All right, so this point that I'm pointing to right here, this ordered pair, is that a solution to this function f of x? No. The solutions have to lie where? On the graph. On the graph. Because it's not a line. Just call it a graph for right now. Okay? Now, question is this. Does this represent a function? Yes. Why does it represent a function?
Because it passes the vertical.
Okay, passes the vertical line test no matter where I draw. I'm not going to draw it because I don't want to mess up this graph when we talked about this. But no matter where I draw this vertical line, it intersects the graph how many times each? Just once, which means that for this x value here, there's how many y values? Just one. For this x value, how many y values? Just one, so on. Okay, and that was a definition of function. For each x coordinate, there has to be how many y coordinates? Just one. Okay? All right. So remember, since this relation is a function, we tend to use function notation. So rather than me saying this is y equal, I'm just going to say this is just f of x. Okay? All right, so let's look at number one now. So number one, we talked about something like that last class period where you wanted to find a function values where you give an f of x and you actually find f of 6, f of negative 2. That was one of the worksheets that's due next class period. Okay, so remember our discussion. This right here means when x is 4, I'm looking for what? For the y value. That's what that means. So if I want to find what f of 4 is, I'm going to first of all locate the point in the graph where x is 4. Okay, now before I go on, I'm going to ask you, in what quadrant would this ordered pair be located? Quadrant 1, 2, 3, or 4? Very good, quadrant 1. Because x equal 4, here's x equal 4, right? And so if I look at the point that's on the graph, that's this right here. Y'all agree?
Yes.
That's that right here. And so that's the ordered pair, 4 comma what?
8.
Very good. So f of 4 is what?
8.
8. So you put 8 in the blank. Okay? Number 2 asks you, what are the x-intercepts? Well, some of you still a little confused about what an x-intercept is. By definition, what's an x-intercept? That's where the graph does what? Across the x-axis. And so in this particular relation, this function, how many times does the graph cross the x-axis? Twice. Here and here, right? And it did not indicate to put this as an ordered pair. So since it did not say an ordered pair, you can just say what? Negative 4, and what's the other one? 8. Okay, negative 4 and 8. That's where the graph crosses the x-intercepts. The graph crosses the x-axis. What is the y-intercept? The y-intercept means where does a graph cross the y-axis? Well, where does the graph cross the y-axis?
At 8.
At 8, right here. All right, so that's the next one. All right, so number 4 is similar to number 1. So the question number 4, when they ask you what is f of 9, they're asking what's the y value. Remember, that means what is the y value when x is what? 9. Okay, so in what quadrant will that point be located? Quadrant 4. Because here's x is 9 right here. I locate the point. Let's say it's this one. The graph is kind of thick, so just do the best you can with where it is. So what do you think the y value is when x is 9?
-3.
-3, not -4. I would say -3, right?
Mm-hmm.
So -3. So you put -3 in the blank. All right. So when you get the worksheet that looks similar to this, make sure you understand what's going on. And again, for some of you, you really need to go back and look at those videos if when you get to that worksheet and you're like, I don't remember what to do. Okay. All right. Number 5 says complete the ordered pair. Well, it's kind of like a different way of writing 1 and 4, isn't it?
Mm-hmm.
So in number 5, I'm really asking, what is f of what? -6. That's the same thing. So I just want to know what the ordered pair is. So just make sure you know the relationships between the way things are written. So -6 blank means the same thing as find f of -6.
7.
So
-7.
let's see, -6, and here's the point right here. Yeah, I'll go with -7. So -6, -7. That's the ordered pair. So what goes in the blank though? -7. All right. Now, let's go to number 6. Now listen carefully to number 6. So you had hardly any difficulty with the previous 5. All right, now listen to number 6. So number 1, let's go to 1 and 4. Number 1 says, what's the y value when x is 4, right? And so basically, you went and you looked up, well, x is 4 here. I got to locate the point, and that point represents the coordinates 4, 8. So y is 8, right? Now, look at the way this one's written. This says, find the values of x for which f of x is -3. All right, now remember, here you got to think of it this way. F of x means the same thing as what? Y. So I'm going to write it as y equals -3. It does help if you do that. Y equals -3. And so the question this time is this. Now remember, make that connection. Here I was asking, look at this. I was asking when x is -6, what is what? But what is y? Okay. Here I'm asking when y is -3, what is that blank? You see the difference? So that versus that. Okay? So what you got to do now is look at your graph, and you may, some of you can look at it right away. Others may need to actually go through the graph like I'm doing here and ask yourself, well, which of these ordered pairs will give me a y value of what? -3. Okay, so what do you think?
-5.
Okay, so when y is -3, you're saying x is -5? Okay. All right, so listen carefully to this. So she's saying, and a couple of people are saying this. So if you look at this point here, you see this point right here? The ordered pair is -5, -3, right? So the question is when y is -3, and does this point have a y value -3?
Yes.
What's the x value?
-5.
-5. So one of the answers is -5. Okay?
Yes.
All right. But
Yes.
is that the only point of the graph that has a y value of -3? No. This one here, which we talked about earlier, didn't we? So what's another x value? 9. Okay? All right, now listen to another way you could have looked at that. Now, some of you who did this without any difficulty, that's great. You shouldn't have any issues on the worksheet or a test. But those of you that may be struggling with this, what you may want to do is, let's go back to number 1. So number 1, it's saying when x is 4, what is what? Y. All right, now y'all agree x equal 4? If I locate x equal 4, that's going to be on the x-axis to start with. So I'm going to take my ruler. I'm going to look at it vertically on the x-axis like this. And then I'm going to locate where does the ruler cross the graph? Well, the ruler crossed the graph here, right? So that is the point where x is 4, which is what? 8. Okay? So notice that my ruler is vertical. It's going up and down, correct? Okay. All right. Now, let's look at y equal -3. For y equal -3, I'm going to look at it horizontally. See, y equal -3. So that's this right here. See this? Well, how many times does the ruler cross the graph? Twice. So I'll put a point here, a point here, because both of those points is going to have what y value? -3. So if I was going to ask, and you would have to estimate this, but if y is -5, am I going to look at it like this, or am I going to look vertically, or am I going to look at it horizontally? Horizontally. And so if y is -5, these are the points right here, which you would have to estimate the x. These are the points where y is what? -5. Okay? All right, so in doing those, it sometimes helps if you look at it in terms, if you have some kind of straight edge to help you. All right. So the same thing for number 7. So this time, I want to know what are the values for x for which f of x is 5. Now remember, f of x means the same thing as y is 5, right? So I'm going to ask you this. Is this correct to say, well, when y is 5, I get this point here? No, because that's when x is what? 5. Very good. So I should be doing what? Horizontally. So when y is 5, because that's where on the y-axis y is 5, correct? So I get this point, and I get that point. So that's the point where y is 5, and that's also the point where y is 5. And all you have to do is tell me what those x coordinates are. So what's the one on the left side in quadrant 2? -2, okay? And what's the one in quadrant 1? 6? All right, good. All right, and so in the blanks, you're going to put -2 and 6. Okay? -2 and 6. All right? Now, let's talk about the vertex. So we haven't talked about the idea of vertex yet because we hadn't gotten to that point. But the vertex, and let me go ahead and do this. So either today or next class period, we're going to talk about graphing quadratic functions. And for right now, all you need to know about the graph of a quadratic function, you know what the graph of a linear function looks like. It's what kind of graph? Linear. It's a line. The graph of a quadratic function will be a parabola. All right, now you don't know what it looks like, the equation, but just know that if you have a graph that looks like a parabola, like this, where it's opening up or it's opening down, that's a quadratic function. So the shape is called a parabola. That's a parabola. All right, or P-A-R-A-B-O-L-A. Okay, parabola. Okay? Notice that if I look at all the points, on the one that's on the left, do y'all see that there's a low point? The lowest point on this graph is here. Okay? Sometimes that's called a minimum point. Minimum point. And if I look at the one on the right, this is the highest point on the graph. So I'll call this a maximum point. Maximum. I don't have enough space, I'll just put max. Maximum point. But it doesn't matter whether it's a minimum point or a maximum point. the minimum point and the maximum point of a parabola is called the vertex. So the vertex. So both of these are called vertices. So let's just say vertex. Vertex. Okay? So the highest point or the lowest point is called the vertex. All right, so a parabola has how many vertices? Just one. Okay? Has just one vertex. So if I go back to our graph then, and I need for you to recognize that this is a parabola, okay? It's going to have a vertex. And in this particular graph, you can very easily tell me the coordinates of this vertex. What do you think the coordinates of that vertex is?
2, 9.
2, 9, right here. 2, 9. So that's what you're going to put here. Okay, 2, 9. All right, put that, you're going to put 2, 9 here. Okay? Now, as far as 9 and 10, we're going to come back to that because we don't have enough information in our discussions to do this right now. Okay? Now go ahead and turn the back. Turn the back. So look at the back one. So we have this graph right here. Now notice the arrows on that one. You see this arrow right here? That means it's going this way, right? Does that graph stop here? No. Okay, keep that in mind. It's going like this. All right. This arrow here, so that means that this graph is keep going which way? Down like that. All right, you understand the graph? Okay. So the questions here are very similar to the previous example. All right. Now this time I just called it g of x this time. G of x. So I think you have enough information now to where all of you, even the ones that came in after class started, to tell me the answer to number 1. What is g of 6? 1. Very good. All right. Because g of 6, remember when x is 6, what is the y value, right? So g of 6 is 1. You have enough information now to where you can tell me what g of negative 2 is. G of negative 2, negative 4. Very good, because that I'm actually labeling the point here. You don't have to, but just for our purposes, when you look back at the video. So g negative 2, negative 4. Is that correct?
Yes.
Okay. So remember, g of negative 2 means what's the y value when x is negative 2.
Okay, so wait, just for clarification, whenever the letters are in front, that's whenever x is that number, right?
Inside the parentheses, x
Yes,
is 6.
yes. Okay.
Yeah. G of x is 6. All right. Now look at g of negative 20. What do you think g of negative 20 is? Why negative 4? All right. So you may say, well, I don't even see a negative 20 for x on here, right? That's okay. Because this right here, doesn't that keep doing this? So that means that all of these y values, we have enough experience. Remember about horizontal lines. When you draw a horizontal line, the y values are the same, right?
Right.
So all of these y values will be what y value? Negative 4. And you have all these x values. Negative 2. When x is negative 2, what's my y value? Negative 4. When x is negative 6, what's my y value? Negative 4. When x is negative 10, what's my y value? Negative 4. When x is negative 12, what's my y value? When x is negative 100, what's my y value? Negative 4. When x is negative 20, what's my y value? Negative 4. Very good. So then number 4 asks you, what's the values of x for which g of x is negative 2? Now remember, g of x means the same thing as what? Y. So you got to think, well, y is negative 2, and I'm asking for what is the x value. This is where you may want to use your straight edge. So when I look at y equal negative 2, You see y equal negative 2 is right here, right? So I'm going to do my straight edge right here. And notice the ruler crossed the graph in how many places? 2. Here and here. So in both cases, if I do the ordered pair, in both cases, my y value is what? No, my y value. Negative 2 in both cases. Now all you have to do now is determine what the x coordinates are. What's this x coordinate for that point here? You said it earlier. 4, yeah. What's the x coordinate of this one? 8. All right, so remember our discussion. Use the rule if you need to. So what goes in a blank? 4, and what's the other one? 8. Okay. All right, number 5 is similar to our discussion from last class period. So it says this. From the graph, you can see that g of 9 is negative 4, right here. Y'all agree? Oops, sorry, wrong one. I'm sorry. G of 9, right here. G of 9, negative 4. Y'all agree? Question is, what is the ordered pair? 9, negative 4. That's what goes here. 9, negative 4. So it kind of makes sense because remember from our last class period, this inside the parentheses represents what variable? X. Outside represents what variable? Y. Okay, good. And now, number 6, you just got to remember we just talked about number 5. Number 6, complete the ordered pair. You're given what variable? You're given x, all right? You want to find which coordinate? Y. So when x is 9, what's my y coordinate? Negative 4. Okay. All right, so the only thing we weren't able to get to for this part was the idea of the domain and range. Okay? All right, but now we're going to talk about it now. Okay, so remember in the last class period our definition of domain? What's the definition of domain? The set of x coordinates. Set of x coordinates. What was the definition of range? Set of y coordinates. So the domain was the set of x coordinates. And the range is a set of y coordinates. Okay? All right, now, from our last class period, I'm going to have to pause this until I can find it. Okay, so in the last class period, remember we talked about finding the domain and range of this? So notice, though, that this set right here, is that a finite set of ordered pairs or an infinite set of ordered pairs? Finite. So if it's finite, you can actually list the domain. Remember that? Okay. So when we talk about this, though, the graph we're looking at now, the parabola, tell me something about how many x values do I have in my domain? An infinite number. Because every point on this graph has an x coordinate and every point has a what? Y coordinate. And you see these arrows down here, it just keeps on going as well, right? Now don't always think that your x coordinates and y coordinates are always just the integers, because they could be decimals and they could be irrational numbers, rational numbers, and so on. Okay? So here's the way I want you to think about this. So I'm going to ask you this. This point right here that I'm looking at, this right here, See right here? It's not on a grid. So that x value could be, listen carefully, that x value I'm going to say is about 7.8. Y'all agree?
Mm-hmm.
Could someone else say, well, could I just say 7.81 if I wanted to? Yeah. Could I say 7.8009 if I wanted to? You see all the different kinds of x values that are on this graph? So when x is 3, is x equal 3 in my domain? Yes or no? Yes or no? Well, if you say yes, you better make sure that when x is 3, there's a point of the graph corresponding to it. Is there? Yes. I'm going to use a ruler. When x is 3, is there a point of the graph corresponding to it? Okay. When x is 6.25, is there a point of the graph corresponding to 6.25? Yes, right here. When x is 9.888888 and so on, is there a point of the graph corresponding to 9.8888? Why not? Yeah, 9.88 is right here. I'm estimating where 9.888 is, right? Isn't 9.888 on this x-axis? All right, I'm just wondering why you said no. I'm just kind of curious why you said no. So when x is 9.888, do I get a point of the graph? Yeah. When x is 12, is that in the domain? When x is 12, right here, let's say. Yeah. So you may say, well, it's not touching the graph, but you got to remember the graph does what? It goes like that. Okay. When x is 100, am I going to get a point on the graph? Yes. When x is negative 1,000, let's say this is negative 1,000 right here. Am I going to get a point on the graph? Yes. So remember, the domain is a set of x coordinates, right? Okay, now here's how I would do this.
Is this negative infinity is positive?
So this is how I would do this. So you see how the graph, you have these arrows that are pointing down like this? It helps if you extend it like this, okay? And in your mind, you're thinking that it just keeps on going down like that. And so since it's keep on going down like that, you're going to ask yourself, you're going to start, since the arrows are going down, or it could be going up, doesn't matter, but you're going to start on the negative side of the x-axis. So I'm going to ask you, let's suppose that this x value right here is negative 1 billion. Is that in my domain?
Yeah.
Yes. At some point, we're going to get a point on the graph. Be way down there. So I'm going from negative 1 billion, negative 100 million, negative 1,000, negative 2, positive 5, positive 100, positive 1,000, positive a billion, and so on. So I'm going from, and I didn't have to start with negative 1 billion. I could have started way before that. So the idea is from negative, you may remember that word, negative infinity to what?
Positive.
Positive infinity. So when I use, and here's the way you're going to write it. You're going to say parentheses negative infinity. Make sure it looks like an infinity symbol. It's like a sideways 8. It looks like a sideways 8. Negative infinity, comma, all the way to what? Positive infinity. Now what that means is this, that my domain is any real number for x. Any real number for x. That's what that domain is. I have no restrictions. Any real number for x. Okay? Now, notice I put parentheses right now, so I need you to put parentheses, and we'll talk about the idea of the parentheses in a little while. So for right now, though, I need you to understand that negative infinity When I say, remember the definition of domain is a set of all x coordinates on the graph, right? So negative infinity means any real value for x. I can use any x value and I'm going to get a point on the graph. 100.7654. When x is that, I'm going to get a y value. Okay? Let's get range now. Now remember when I did the domain, remember domain is a set of x coordinates? I went along which axis? The x-axis. Okay? That's how I did this. The range is a set of which coordinates? Y coordinates. All right, I'm going to ask you this. Is my y value, remember, I'll look at all these points, am I going to get a y value, put that here, am I going to have a y value of 20? Am I going to have a y value of 20? Why not? Well, my y value of 20 is way up here, right? Because this is a y value of what? 11, y value of 20. And notice that the vertex is the highest point. So there's no other point above that. So that kind of means then that the largest y value I'm going to have will be what? 9. And so the way you want to think about this in terms of the ruler, that ruler idea is, now you see these arrows down here? Means the graph keeps going down. So that means this, if I look on, now remember when I go along the y-axis, I do the horizontal, just like we did earlier. So when I go along the y-axis, you always start from bottom up. When you do the x-axis, you start from left to what? Right. Y-axis, bottom up. You're going to see y. X-axis, left, right. All right, so you see these arrows? So I'm going to ask you this. Is my smallest y value negative 11? No, because there's some arrows on here, so it kind of like it's pushing this ruler down, right? And so am I ever going to bottom? No. So think of what idea then. I'm going from where? Negative infinity all the way to what y value? 9. Okay? So the way you write this is this. Now listen carefully, and that's where you're going to have to remember this. Is it have to be written like this. Negative infinity, comma, negative infinity, comma, 9 with a bracket. Okay, negative infinity, comma, 9 with a bracket, not parentheses. Okay, so listen to the difference between, and you're going to see this a little bit better when we do some other problems. So first of all, the 9 is in a bracket because when you use bracket, it means that that point is part of my graph. That 9 represents a y value in which the point is on the graph. So when y is 9, is this point that I'm pointing to, is that a point on the graph? Is that a solution? Yeah, that point's a solution. So I have to include 9 as the as a value for the range, and it has to be a bracket. Okay? Now, whenever, and you may say, well, why are these parentheses here? Well, whenever you use negative infinity and infinity, see, negative infinity is not a number. You can't tell me what that y value is. It's just an abstract idea, right? So you're always going to use, for negative infinity to infinity, you're always going to use parentheses. So make a note of that. When talking about range and domain, if I have negative infinity and infinity, I am going to use parentheses. If I have a number, for us, next semester, you're going to see sometimes where you're going to get holes in the graph and you can't use a bracket any longer. But if I have a number, it'll be a bracket with it. Okay? All right, now, here's what I want you to do. Take out that handout we started on the other day. So we got to start with number 7. So go back and get that handout. So take that handout out. So last class period, if you remember these problems, you were asking, is this relation a function or not? Remember that? Mm-hmm. Okay. Now what I want to do is the part where it says determine the domain and range. All right, determine domain and range. So that's the part we're going to look at now. All right, so let's talk about domain and range. Number 7 is very similar to what we just did, except this time we have this parabola that is pointing which way? Up. All right, now I'm going to ask you this. Based on our discussion with the previous problem, what do you think the domain is? As an interval? Domain, what do you think? Huh? What'd you say? I can't hear you. What do you mean infinity? You're not going to say infinity. So when talking about domain, you always start from the left x-axis, go to the right, correct? So when you see these arrows, 2 arrows on either side, either pointing up or pointing down, you got to remember it keeps on doing this, right? So then when you go along the x-axis, you ask yourself, all right, is it going to be negative infinity that I'm going to start with? That's what you ask. Yeah. And so you say, well, if I'm going to use if I think it's negative infinity, let's start with negative 1,000. If x is negative 1,000, let's say negative 1,000 is right here. I'm going to get a point on the graph. Mm-hmm. Yes. Let's move it further to the left. If x is negative 1,000,000, am I getting a point on the graph? Mm-hmm. Yeah. So by that situation, then I can say that my domain is going to start where? Negative infinity. All the way to, do I ever stop along the x-axis? No. All the way to what? Positive infinity. So the domain, negative infinity, comma, all the way to what? Don't say negative infinity, guys. Listen carefully to this. When listing something as an interval, you go from smallest to largest. So it'll be from negative infinity to what? Infinity. Positive infinity. Okay? Don't say infinity to negative infinity. You're going the wrong way. You go from left to what? Right. To right. Negative infinity to what? Positive infinity. So that means that no matter where I am on the graph, my x values will be any real number. Is that true for my range?
No.
Will my y values be any real number?
No.
No, because if you look at the vertex, what's the smallest y value? 1. No, y value. 1. Your y value, right? Mm-hmm. Okay. So when talking about the range, you go along which axis? Y, and you always start at the bottom part. So when I have my ruler here, am I touching a graph? No. So I start touching the graph when I get to what y value? 1. All the way to what?
Positive infinity.
Positive infinity, because I never stop. Okay? You got to use your ruler to help you, or a straight edge. Now remember, we start with 1, right? Whenever we start with a number, you must use a bracket. So range will be from positive 1, bracket positive 1, all the way to positive infinity with a parentheses. Okay. All right. Now, I've written, these right here are called intervals. These are interval notation. That's what this is. And on the worksheet, on the test, it'll say write interval notation. So that's the way you're going to write it. On my math lab, though, they have there are different ways of writing your domain and range. For the range, listen carefully so you'll know what you're dealing with when you do my math lab. For the range, remember the range is a set of y coordinates? Y'all agree? Right. And when I look at this, in your mind, this says that my y coordinates are going from 1 to what? Infinity. Well, isn't that the same thing as this inequality symbol that I'm about to write? Y'all agree that this right here is the same thing as saying y is greater than or equal to 1? Yes or no?
Yes.
Yeah. Y greater than or equal to 1 means 1 to what? Infinity. Notice it's equal to, why is it equal to? Because the bracket. Now remember, in a previous course, y greater than 1 means you have parentheses. This is a bracket, so you must use the equal symbol with it. Okay. All right. Now, this is going, this right here, the one that says negative infinity infinity, you can't write it as an inequality symbol. So in my math lab, the way it's going to look is it's going to say this. Remember a while ago I wrote the word all real numbers? So that's the way it's going to look. It'll be all real numbers. So you choose the one that says all real numbers because you're not going to see this interval notation in my math lab. You'll see it written like this. Okay? All right. Now let's look at number 8. So based on the 2 examples we did, I think you all can now tell me the domain and range of number 8. What's the domain? Negative infinity and infinity. In my math lab, what will it say? All real numbers. Okay, good. What's the range? Negative infinity, comma, all the way to 4. Very good. With a what? Bracket. Awesome. Now be careful with that one. What do you think the inequality symbol will be? Now remember that you got to use y. Always put y first. Y is what? Are you going to say a greater than equal to or less than equal to? Less than equal to. Good. So y is less than equal to what? 4. So always put the y first when doing an equality symbol. All right, so that's number 8. So again, if you need to use a ruler, you use a ruler. So the domain will be from negative infinity all the way to positive infinity. The range, see the arrows? It's pulling this ruler down all the way to the idea that negative infinity. And then I stop at the highest point, which is the vertex. And what's that largest y value? 4. Okay.
So it's okay if I just find the vertex and then I write that?
However you want to do it. But it's got to be, your answer's got to look like this, though. Okay. That's the only way to write the answers, like this. Now, number 9 is a circle. Okay, 9 is a circle. All right. Listen carefully. Number 9. Talk about domain. Remember domain, you go along which axis? The x-axis. So, what do you think the domain is in number 9?
To 6.
All right, I'm glad that that none of you said negative infinity. For one thing, there are no arrows here, right? It's a circle. So when I go along the x-axis, where do I start touching the graph? When x is negative 1. And I get all these real numbers inside all the way to what x value? 5. So as interval notation, you're going to say bracket what? Negative 1, comma, all the way to what? 5 with a bracket. So that's your domain. Yeah, the only time for right now, for us, for domain and range, the only time you're going to use parentheses is if you say negative infinity or infinity. Okay, now remember why these are brackets, because this point here that has x value negative 1 is a solution. Same thing here. That point right here that has x value 5, that point right here is a solution. Now let's talk about how to write this as an inequality, though. All right, listen carefully. So you got to remember some things from a previous course. So the reason why, right here, when we go back to this one, the reason why you saw just one inequality symbol the greater than equal to, was because there was an infinity symbol there. So this says that my y values are any number that's from 1 all the way to what? Infinity. Okay, that's what this means right here. This inequality symbol means that my y values is any number that's from 4 all the way down to what? Negative infinity. So from negative infinity to 4, that's what that means. But when I look at this one, this right here says that my y values are between -5 and what? I'm sorry, -1 and 5. Now, you got to remember this from the previous course when you dealt with inequality symbols. Look, I'm going to write this. So remember, the domain is a set of which coordinates? X. So I got to say X. So X is less than or equal to 5, and at the same time has to be bigger than or equal to what? -1. So that's how you write that interval. So you use that two inequality symbols. Okay? And remember, and some of you messed up with this because it does happen in that particular course where you have this one symbol going one way and another symbol going a different way. They got to be pointing in the same directions. So I would do this part first. X is less than or equal to 5 because that says that my largest x value is what? 5. And then put the symbol less than or equal to again, and then my smallest x value is what? -1. Okay? All right, so my math lab, whenever it's bounded by two numbers, you're going to use the two inequality symbols. So let's talk about the range then. As interval notation, what's the range? Very good. -3 all the way to what?
3.
+3. So always go from smallest to largest. So you have to put what first? -3, bracket -3 all the way to +3 with a bracket. Now, just like we did with the domain, you do the same thing with the range, except this time I use what letter? Y. So let's do the 3 first. So you can say y has to be what? Less than or equal to 3. You're going to do the symbol again, less than or equal to, like that, and you're going to put what number here? -3. All right. Okay, so that was that one. Let's look at 10. For that one, the domain, let's do the domain first for number 10. So I think you can all tell me the domain here. As an interval notation, what's the domain, do you think?
15.
It's not just 15. What's the domain?
Negative infinity to 15.
Negative infinity all the way to what? 15. Okay? So you're going to say parentheses negative infinity all the way to 15 with a bracket. Because remember, the arrows are going this way, right? So it's kind of like you're not going to say, well, this is where my graph starts because you have arrows here. So it's kind of pushing this ruler to the idea that negative infinity. So you go from negative infinity all the way, and then it stops when x is what? 15. Okay. Now, based on our discussions from previous problems, how do you write this as an inequality? X, good. Less than or equal to. That's how you do it. You don't say equal to less than. You say what? Less than or equal to. And then what do I put? 15. That's the only way to write it. Don't say x is greater than or equal to 15 because that's not true. Y'all, you understand that if you put this, you're indicating this interval instead? Y'all agree? All right. Is that the same thing? No. All right, good. So remember, that's not the right one. Okay, now let's talk about the range. So range, you go which way? The y-axis, you always start at the bottom. Now, be a little bit careful. So some students get a little confused here. So I'm going to ask you this. If I'm looking at this y value right here, is that ruler, remember that ruler doesn't stop here, just think about it extending. Is that ruler going to touch that graph?
Yes.
Yes. You just got to remember, this arrow just keeps on going down like this. You got to visualize it. Okay? So if I'm at negative 1,000, am I going to get a point on the graph?
Mm-hmm.
Yes. Negative 1 million, am I get a point on the graph? Yes. So I'm going from where? Negative infinity all the way to, do I ever stop? Okay, who said yes? Why'd you say yes? Why do you say I stop? You say you stop here, is that what you said? Who said yes? You got to tell me. I don't. Someone said yes. I got to understand why. You. All right. No, you're not, right? Because this thing keeps on doing this. I'm not drawing it very well, but you see it keeps on going this way, right? So I'm going from negative infinity all the way to what? Positive infinity. Yes.
Do we ever need to know how to do negative infinity and positive infinity with the y is equal to less than symbols?
No, remember you don't, the only way to write this is to say what? All real numbers. You can't write it like, you can't rise in inequality. You have to say all real numbers. The only time you're going to rise in inequality like this is if it's bounded by two numbers or one's a number, one's in negative infinity or infinity. But that was a good question. Okay, that was number 10. Let's look at 11. I think you can all now do 11. You can do 11 as you're driving home in your mind. You're thinking, okay, I have this graph that looks like this. The light's green, so I can still go further and still think of this. What's the range? Let's do the range first. What's the range? What's the range? So say it again. To positive infinity? So if you say negative infinity, positive infinity, this is what you're telling me. You're telling me this,
It's negative.
that it never, the ruler never stops. I did say the range. The range is a set of y coordinates, not x coordinates. All right, so you may want to change negative infinity to what? 4. Yes. Very good. And you always use the bracket with the number, right? Because when you say 4 and you look at that point, is that point right here that has y value 4, is that a solution?
Mm-hmm.
Yes, that's a solution. So you got it included, so it's a bracket. Now let's talk about the domain. Oh, let's write this as an inequality. It's range now, so be careful, guys. Make sure you use the correct letter for range and the correct letter for domain. The range, you're going to use what letter? And you're going to say y is greater than or y is less than? Less than or equal to 4. Okay, good. What's a domain? Negative infinity to positive infinity because of the arrows, right? So if this is negative 100, am I getting a point on the graph? Yeah. If this is negative 1 billion, am I getting a point on the graph? Yeah. So it's from negative infinity all the way to, and do I ever stop? No. Positive infinity. And in my math lab, you're going to say all real numbers. Okay, so that was number 11. Let's go to number 14. Let's skip 12 and 13 for right now. Let's go to 14. All right, 14. So it's a line this time, but you can still answer the question of what's the domain and range. What's the domain, do you think? Negative infinity to positive infinity. Because if, remember, you're along the x-axis, see that's an arrow, keeps on going, right? So I'm going from negative infinity all the way to positive infinity. So any value for x will be on the graph. What's the range?
Negative infinity to positive.
Same thing, negative infinity to what? Positive infinity. So use the ruler to help you. So in terms of these lines, if they're slanted, if they're falling or rising. Do y'all see that if I have a line that's falling or rising, the domain and range is this? Okay. Now look at number 15. Let's do the range first. The range. Now remember, number 15 is a vertical line. Remember we said a vertical line is a function and not a function? Not a function. Okay, but we can still talk about domain and range of this relation, even though it's not a function. What's the range?
Negative, negative, positive.
Yeah, because the arrows are pointing down and it's going up, right?
Right.
So notice that if I look at any of these points right here, I have any y value.
Mhm.
But now this is where you may get a little hung up. What is a domain?
Negative 5.
In every problem we've done up until this point, the domain and range in all cases has been an interval. And I'm going to go back and I'm going to ask you these questions. How many x values are in this interval right here? An infinite number. How many y values are in this interval right here? 1. Really? What's the only y value in that interval? So you're telling me that 3 is not in that interval? I'm going to ask you again. How many y values are in this interval? That's not telling me how many. How many y values are in this interval? We just talked about it. You can't. All right, I'm going to ask you this. Here are my points, right? You're telling me that there's only one y value on this graph?
Right. No.
All of these indicate what an x and a y, right? How many y values are on this graph? An infinite number. Not 1, not 2, an infinite number. What? Okay? An infinite number. There's just not one y value on this graph. There's not 2. Same thing for domain. How many x values are in this interval? An infinite number. So if you go back to all of the ones we've done, the domain and range was an infinite set of numbers.
I have a question. So since it's infinite, but it stops at 4, how do we word that?
I'm just asking how many x values are you? You just say an infinite number.
Okay.
Yeah. All right. Now we go to 15. Let's talk about the domain. What is the domain of number 15? Anything else? No. So in number 15, how many x values are in my domain? Just 1. It is what? Negative 5. Negative 1 is not in my domain. 2 is not in my domain. It's just what? Negative 5. Now here's how you do that though. Now remember, we did the intervals because it was an infinite number, right? Is this an infinite number for domain? No, it's just one number. So here's how you're going to say this. It still has to be written as a set. Remember the set notation, the braces? You're not going to use interval. You use interval to indicate an infinite set of numbers. You're going to do this. You're going to say, well, the domain is just a set that has what number in it? Negative 5. Negative 5. That's all you do. So that's a situation where you're not going to use an interval. You're going to use a set and you're going to list it. Now, is it inequality? I'm sorry. Well, you remember we also use the inequality symbols? All right, now be careful. This says, now remember this, we're going to come back to it. This says that negative 5 is which value? X. Do y'all remember that that this line right here, this vertical line, represents x equal what? Negative 5. Remember that? You had that on a previous worksheet? So in my math lab, though, on my math lab, it's not going to have it written like this. It's going to say x equal what? Negative 5. That's what it's going to say. No inequality. You're not going to say less than, because less than would imply an infinite number. It's just one thing. Now look at 16. So I think you can do 16 now. 16 is that horizontal line, isn't it? 16 is that horizontal line. So the domain's an easy one for people here. What's the domain?
Negative infinity, positive infinity.
Yeah, negative infinity all the way to what?
Positive.
Positive infinity. All right, now let's talk about the range. Okay, so first of all, how many x values are in my domain? An infinite number. How many y values are in my range? Just one. It is what y value? 5. So you're going to list it like this on the worksheet. On my math lab, you're going to say what instead? Y equals 5. Very good. Okay? Very good.
This is my first time ever understanding this.
Yeah, it helps. It helps if you use the idea of rulers and to help you with this. Okay. All right. So it's not that difficult. Use the idea of rulers and think about the definitions. It helps know the definitions as well with this.